And in fact, a month ago, it was only going to be about the Haiti earthquake, but then Chile happened. And so I'm putting a little bit in about Chile just to illustrate the differences between Haiti and Chile, because I assumed at the time that I would get a lot of questions about that, so I'm anticipating the questions before they get asked. However, I do think in following the media coverage that the press has done a reasonably good job in elucidating the differences between the two, so you may already know all of this already. And a lot of this came about because we were working in the Caribbean and have been working in the Caribbean since the mid-1990s, some of my colleagues since earlier than that. And we had been working in Haiti, and we had published a paper where we made a statement that we thought was innocuous enough, but it ended up getting picked up by the press that our research group in collaboration had predicted the earthquake. And I will show you the one statement that we made and what led to this. So just to start, here are two seismograms from a station at Crowley, Texas. Here it is for the Haiti earthquake, and here it is for the Chile earthquake, just to start us off. And I think the one thing you can notice is, yes, the amplitudes are a bit bigger in Chile than in Haiti, but you can also see that it lasted a lot longer. So that was one of the main differences in the two events. Okay, so for all the geologists, I know I don't have to remind you, but for all of the non-geologists, I'm going to remind everybody that the Earth's outer layer is composed of rigid plates that move relative to each other. And here we have the maps of the plates. You can see the South American plate here, the North American plate here. There are actually continents on this map and oceans, but I guess they're getting a little bit washed out from the projector. And here I'm just plotting where the Haiti earthquake was and where the Chile 8.8 earthquake was. There was another earthquake in Chile today that was quite large, which was just like right here. So it's still on the plate boundary, and this is actually on the plate boundary. It's just difficult to get it exactly right in the PowerPoint. But the point is there are lots of earthquakes along the plate boundaries, so the fact that we have an earthquake in Haiti and an earthquake in Chile is not all that surprising to us. So here's the situation in Chile. Chile here, the earthquake's down here, and here's Santiago, the capital of Chile. And Chile sits here along the boundary between the Nazca plate here, which is subducting below the South American plate here. The arrows here just show the motion of the various plates relative to South America. So if you hold South America fixed, what the other plates are doing relative to South America, and the Nazca plate is moving toward South America. Okay? And then subducting below it, and here's the trench in here. If you look at Haiti, I believe that we're going to have some issues with changing PowerPoints, but hopefully you guys will be able to see. So Haiti's the boundary of the Caribbean and the North American plate, and you can see here's a detailed map that shows that. So Santiago's somewhere down over here. So here's where the Haiti earthquake was. This is the Caribbean plate. Here's the North American plate. And here's the boundary between the two. And this just shows the geological structures along that boundary. And then here you can see the Enriquillo Plantain Garden Fault Zone. And the Enriquillo portion is the portion in Haiti. The Plantain Garden is the portion in Jamaica. And this is the fault that ruptured during the Haiti event. But remember, it's still sitting here in the plate boundary. The primary difference between Chile and Haiti in terms of how people reacted to the earthquake is that the motion between the Caribbean and North American plates is slow. Okay, so the relative plate, but the relative plate motion, if you look, the relative plate motion between here's Haiti and here is South America, there's Santiago. Each one of these dots is an earthquake. The colors correspond to different